Recording. So, a z-score is defined a z-score is how many standard deviations a data point is from a mean. Okay, so I'm going to do a real basic example here. Pretty good, besides the end. Go ahead and try to draw a bell curve real quick. Anybody have a really good one? Anybody proud of themselves today? Are we all? No, we're all just gonna not show anybody? Okay, all right, got it. Was yours good? No, don't tell anybody. Okay, all right. Where's the mean in a bell curve? Right in the middle. Okay, let's say that the average amount of pair of shoes that teenagers have that fit them are 6. That's average. Okay, and let's say the standard deviation is 2. This might be a little low. Is anybody thinking this is a little low?
Yeah.
Okay, you want me to up my number?
No, I like cleats.
Should we keep 6? What do you say?
You kind of like cleats and stuff.
Let's count like regular shoes that you wear to school,
Like
okay?
cleats still? Okay, so never mind.
Yeah, let's just do regular shoes you wear to school, okay? So let's say on average 6.
Tennis shoes.
Okay, what?
Tennis shoes.
Tennis shoes, sandals, that kind of stuff. Whatever like you'd be wearing at school, not like work boots or cleats or, right. But like not specialized shoes, I guess is what I'm saying. Okay, and then let's say that the standard deviation is about 2. So 1 standard deviation away would be what? 4. 2 standard deviations away would be 2. Okay, over here we've got 8 and 10. Which means, who are my outliers? 2 and 10? Beyond 2 and 10. So my outliers over here, my outliers are people who have 1 or 0 pairs of shoes or more than 10 pairs of shoes that are daily shoes that they would wear to school. Make sense? Okay, everybody okay with this? Now here's my question. How would I figure out if somebody had, this is, now, you don't answer me out loud, I need you to think about this because this is the thing that's worth a pen, okay? You need to think about how many standard deviations away would somebody with 9 shoes be? Because they're not on the chart, right? Here's 8, here's 10. How many standard deviations away is this?
2. No, 1.
This is 1 standard deviation. Okay, so let's talk about z-scores instead. Maybe I'll do that. Okay, let me rewrite this. So my 6 was in the middle, right? Because that was my mean. And this is 1 standard deviation. This is 2 standard deviations. This is -1 standard deviations, -2 standard deviations. How many standard deviations is this one right here? Right in the middle. 0. 0 standard deviations away from the mean because it is the mean. Everybody understanding that? These are z-scores. Right here, all of these are z-scores. It's just how many standard deviations away a data point is from a mean. So my question is, what would the z-score be for 9 shoes? Now, 9 shoes, I'm guessing a lot of you are thinking of the answer right now, right? Are people thinking of 1.5? Between 8 and 10 is 9, right? Between 1 and 2 is 1.5. We all good with that? My question is, what if you had something that was not exact, not something you could figure out, like we're going to try to create a formula for a z-score. So I know this is impossible, but what if I said somebody had 9.2 shoes? Okay, and I know it's ridiculous, right? nobody would have like a chunk of a shoe.
My dog ate
Yeah, your dog ate some, he only left 0.2 of one shoe, okay? It's real bad. So now you got 9.2 shoes. So how many do you have now? Anybody want to just take a guess?
Two.
Yeah, Tyler? 2 would be 10.
Or would it be 1?
1 would be 8.
1.1?
And we're looking at 9 we decided was what?
1.5.
1.5. So what's 9.2?
1.6.
Maybe 1.6, 1.55, something like that, right? But what, I need a formula that would be able to do this for me. Okay, so the data point is X. The standard deviation is sigma, and the mean is mu. Now, it's going to be a formula that involves X, sigma, and mu, and this is what the pen is somebody who can tell me what they think the formula would be to figure out a z-score. You can figure out the formula yourself just by thinking about 9. What is, tell me again, guys, in this problem, here's my data point, right? That's X. What's my mean?
6.
6. Here's my mu right here. What's my standard deviation? 2. Okay, so, and we know that the answer would be 1.5. So something you can do with 9, 6, and 2 to get to 1.5. Okay, I'm going to give everybody some thinking time, so think about it. And when you tell me your formula, I want it to have X, mu, and sigma in it. Write it down if you need to. I'll give you some time to think. 9, 6, and 2. I'm trying to get 1.5 from that. All right, hands up if you want in. 1, 2, 3. You're 3. 4, 5. You're 5, cool. 1.
I did x minus mu divided by sigma.
Yes, that's right. X minus mu over sigma. I'm going to sing this an obnoxious amount of times. X minus mu over sigma. X minus mu over sigma. It is the most popular formula in statistics. It happens constantly with bell curves. So you take your data point, you subtract the mean. By the way, that is the deviation. Remember, x minus mu is a deviation, and then you divide by sigma to see how many of those there are. So for example, let's think about this. If I was putting in 10 into this formula, I would take 10, which is your data point, minus your mean, which is what? 4. It's like a span of 4, right? And then we want to know how many standard deviations are in a span of 4. Well, the standard deviation is 2, so if I took 4 and divided by 2, it would say, oh, it's 2 standard deviations. The only difference, if it was negative, is the x minus mu, this number on top would be negative, which would make the whole thing negative. So z-scores can be positive or negative. Everybody understand? Cool. All right. So what we're going to do right now, oh, and Nolan, you want a pen? Or would you like 2 of those prizes?
I'll grab 2 pens.
Okay. I guess my pens are not that good anymore, huh? All right, so we need 2 examples, or we're going to do an example for us. All right, so example 1. We're all going to find out our own z-scores for our heights. So I've got to look up the data on the United States. Women and men are different. Right now, what you need to do is find out your height in inches. How many inches are in a foot? 12. So, for example, my height is 5'2" and a half. And that half is important because my husband is 6'2" and he thinks he's a foot taller than me, and that's not true. Okay, he's 11 and a half inches taller than me, and that's very different. We're not rounding up. But let's say that I was 6'3" for just to make it easy because you guys aren't going to be doing half stuff. So we'll say I'm 6'3". What am I looking for? There it is. All right, so men, if you consider yourself a man, or going to be one, that is 69.9 inches for the mean.